Hello Year 11 Mathematics Advanced students. Today we're continuing on with the topic of functions and we're learning about the gradient of a straight line. Hopefully you know about the gradient of a straight line from stage 4 and 5 mathematics, so we're just going to go over it quickly in today's theory notes. So the gradient of a line measures its slope. It compares the vertical rise with the horizontal run. So you should know that the gradient of a straight line equals the rise over the run, where positive gradients lean to the right and negative gradients lean to the left. On the number plane, gradient is a measure of the rate of change of y with respect to x. Now let's have a look at the gradient formula. So it's all well and good to know that gradient is rise over run, but sometimes when we get 2 points, we need to know how to work out the gradient. So the gradient of the line joining points x1, y1 and x2, y2 is m equals y2 minus y1 over x2 minus x1 is our formula that we use. And you can see it demonstrated over here on the picture. So to work out the gradient of our line, we have our 2 points A and B. And so our rise is our y2 minus y1 and our run is our x2 minus x1. So for our example, we want to find the gradient of the line joining the points 4, 3 and negative 6, 7. So what we're going to do first is we're going to write out our gradient formula. So our gradient formula is m equals y2 minus y1 over x2 minus x1. Next, we're going to go back over to our points and we're going to state what each point is. So 4, 3 is the point x1, y1, and negative 6, 7 is the point x2, y2. So that means x1 equals 4, y1 equals 3, x2 equals negative 7, y2 equals, x2 equals negative 6, y2 equals 7. So now that we know our formula and we know what points we're going to substitute into our formula, we can simply just substitute them in. So we'll have m equals our y2 of 7 minus our y1 of 3 over our x2 of negative 6 minus our x1 of 4. So then 7 minus 3 is 4 over negative 6 minus 4 is negative 10, which equals the simplified answer of minus 2 on 5. And that's how you find the gradient of a line joining points. Next, we're going to move on to the angle of inclination of a line. So the angle of inclination of a line is, the angle of inclination theta is the angle a straight line makes with the positive x-axis measured in anti-clockwise. So we already know that m equals rise over run. What we need to do is we need to have a look at our picture over here, and we have an angle. And what we can remember from stage 5 trigonometry is that when we have an angle theta that we're trying to find and a right angle and two sides, we use SOHCAHTOA. So now let's label our triangle. So in relation to our angle theta, we have the opposite side to theta is over here. Our hypotenuse, which is opposite our right angle, is here. And the side next to our angle is our adjacent side, which is here. So if we have a look, our rise and our run is our opposite over our adjacent side. So that means m equals opposite over adjacent. And we know that opposite over adjacent is tan. So that means the angle of inclination of a line is m equals tan theta. So the gradient and angle of inclination of a line is m equals tan theta, where m is the gradient and theta is the angle of inclination. So we can have a positive gradient or a negative gradient when it comes to finding the angle of inclination. So if we have a positive gradient, it means our acute angle, our tan theta, will be greater than 0. And if we have a negative gradient, we'll have an obtuse angle. So our tan theta will be less than 0. So let's have a look at this by having a go at some examples. So for the first example, find the gradient of the line that makes an angle of inclination of 135 degrees. So what we know is we know our formula. We know that m equals tan theta. And if we look at our question, what we're trying to find is our gradient. So we're trying to find m, and we know the angle of inclination is 135 degrees. So let's substitute that into our formula. So we have m equals tan 135 degrees. And so then we'll put that into our calculator. And so when we put tan 35 into our calculator, what we do is in our calculator, we will hit our tan 135 equals. And then on the Casio, once you hit tan 135 degrees, you will get an answer of -1. So therefore, our answer to m equals 135 degrees is m equals a -1. And that is our gradient that we have found. So for example 3, we want to find, correct to the nearest minute, the angle of inclination of a straight line whose gradient is 1.5. So in this question, we don't know the angle of inclination. That's what we're trying to find. And we're trying to find it correct to the nearest minute. And we know our gradient. So using our formula, we have m equals tan theta, where we know what our m is. We can sub our m of 1.5 in. So we'll have 1.5 equals tan theta. And then remembering back to stage 5 trig, what we want to do is when we want to find theta, we inverse tan. So we divide both sides by tan, which is called inverse tan. So we'll have theta equals the inverse of tan, so tan to the power of -1 of 1.5. And so how we put this onto our calculator is we hit shift tan. So we hit shift tan, our 1.5 equals. They're all our buttons that we press. So shift tan, 1.5 equals, and we get the answer of theta equals 56.30993.247. But on our calculator, we want to change this to degrees and to the nearest minute. So then what we do is our next step is we press the degrees, minute, and seconds button, like so. And so then that gives us an answer of 56 degrees. Ooh. So that gives us an answer of 56 degrees, 18 minutes, and 35.76 seconds. But we want this to the nearest minute. So when we're calculating to the nearest minute, we want just that much of information. So we want the degrees and minutes. But what we need to keep in mind is that if our seconds are over 30, we need to round up. So because our seconds are over 30, we need to round this up. So our answer is going to be 56 degrees and 19 minutes. Okay, so note when rounding, minutes to degrees or seconds to minutes, we round up at 30. There we go. So that is our answer. So our angle of inclination for a straight line who has a gradient of 1.5 is 56 degrees and 19 minutes. On to our next one, we have to find correct to the nearest minute the angle of inclination of a straight line whose gradient is -4. So we write our equation or our formula out. M equals tan theta. We sub in our gradient of -4. So we'll have -4 equals tan theta. We then divide both sides by tan. So we'll have theta equals the inverse of tan of -4. And then we put that into our calculator. So how we put this into our calculator is we go shift tan -4 equals, and so we go shift tan -4, and when we do this we get theta equals -75.96375653. And remember, we want to find it to the nearest minute, so we need to press our degrees, minute, second button. And when we press this, we still get -75 degrees, 57 minutes, and 49.52 seconds, which equals, when we round up, -75 degrees, 58 minutes. So we have to round up because our 49.752 is greater than 30. Okay. However, a negative gradient means that the angle of inclination is obtuse. So to find this angle, we then need to come over here and we need to just subtract the acute angle from 180 degrees. So to find our answer, we have theta equals 180 degrees minus our 75 degrees, 58 minutes. So we get theta equals 180 minus 75 degrees, 58 minutes, which equals 104 degrees and 2 minutes. And so that is our angle of inclination. So whenever you get a negative number here, whenever you have a negative number as your answer, when you've done it, you will need to subtract it from 180 to find your actual angle of inclination. And when it's negative, when it has a negative gradient, it means it should be an obtuse angle. So it should be greater than 90 degrees. Finally, we're just going to look at the gradient intercept equation of a straight line. So the gradient intercept equation of a straight line is the linear function with the line y equals mx plus c has a gradient of m and a y-intercept of c. So we have some examples. We want to find the gradient and y-intercept of the linear function y equals 11x minus 3. So our gradient equals our m, which in this case is our 11, and our y-intercept equals our c, which in this case is -3. Okay, so our gradient was our 11, and our y-intercept is our -3. Actually, let's do those the other colours way. Gradient, y-intercept, y-intercept. So finally, we want to find the gradient of a straight line with an equation 3x plus 2y minus 6 equals 0. So what we want to do for this one is we first need to change the equation into the form of y equals mx plus c. So what we're going to do is, for this equation, we're going to move everything apart from the y onto the right-hand side of the equation. So we'll have 2y equals -3x x plus 6. So I just minus 3x to both sides and plus 6 to both sides to get the 2y by itself. Then I'm going to divide everything by 2, or both sides by 2. So we get y equals negative 3 on 2x plus 6 divided by 2 is just 3. And so now that we have gotten our equation in the form of y equals mx plus c, therefore our gradient equals our m. So our gradient is our number, or our coefficient of x. So in this case, our gradient is minus 3 over 2. So we have to move everything to the one side so that we have it in the form of y equals mx plus c, and then whatever our coefficient of x is our gradient. Okay, so that is a recap of how to find the gradient of a straight line. If you're following the Maths in Focus textbook, you would now, for advanced students, so for advanced, you would do exercise 305, and for extension 1 students, you would do exercise 405.